So the last subtopic on the carboxylic acid are reaction. So there are several types of reaction. So we go one by one, but only the general of reactions only, because the next chapter involve the mechanism and involve all this reaction to more detail in the next chapter. Okay, first reaction, formation of salt. So there are two types. Okay, first by neutralisation. Okay, so as you can see here, carboxylate salt are soluble in water because of from this neutralisation it produce the carboxylate salt. So this one is carboxylic acid react with any kind of the bases, okay, to form the salt and side product water. Okay, by adding a strong acid. Okay, this one example for the basis, but for the by adding of the strong acid like chloric acid, so regenerate carboxylic acid. Okay, so there are two situations, means by neutralisation, if you neutralize with the basis, so the products form in the form of salt. If you add the strong acid such as sulfuric acid, chloric acid, so will regenerate the carboxylic acid. Okay, so here by using the litmus paper, so from blue litmus paper turns to the red, okay, due to the form of salt. Okay, this carboxylic acid react any kind of basis, so become salt. Carboxylic acid react carbonate and hydrogen carbonate to form carbon dioxide, water and salt. Okay, so this one is example of the carboxylic acid react with the carbonate and hydrogen carbonate. Okay, this one the example of the strongest basis, and this one for the carbonate and hydrogen carbonate. So the end product is salt of carboxylic acid and side product carbon dioxide and water. Okay, next is the reaction with electropositive metals. Okay, this reaction, formation of salt, involve the reactive metal. So we're using the calcium, magnesium and iron. Okay, carboxylic acid react with the reactive metal product magnesium ethanoate. Okay, so this product is slightly reactive. So next reaction by reduction to form alcohol. Okay, so we're using the reducing agent such as lithium aluminum hydride. Okay, this is general equation for the reduction of alcohol. Reduction to alcohol, carboxylic acid, okay, react with this condition to form primary alcohol. Okay, the condition it must be using lithium aluminum hydride and the presence of the solvent ether and also source of proton, so we'll give the primary alcohol. So benzoic acid can be reduced to the phenylmethanol. Okay, reduce phenylmethanol using the strong reducing agent in a low temperature. So the products form is alkoxide intermediate and then give source of proton hydrolysis. So this intermediate produce the primary alcohol. So next is formation of acyl chloride or acid chloride. Okay, carboxylic acid react with this reagent to form acid chloride and side product. If we are using the PCl5, if we using the tiny chloride, so the product is acid chloride. Okay, this one OH from carboxylic acid replaced with the Cl, and side product is SO2 and also chloric acid. Here are example. So next is formation of ester. Okay, So means that carboxylic acid heated with alcohol, okay, any kind of alcohol, and then the presence a little concentrated sulfuric acid, so the ester will form. Okay, carboxylic acid react with the alcohol, the presence of sulfuric acid, so the ester will form. So next, formation of acid anhydride. Okay, first react sodium carboxylate with acid chloride to product is acid anhydride. This one is the general equation. For this chapter, for only the general equation for the reaction, you must know. So acid anhydride is also formed from dehydration reaction. Okay, carboxylic acid is heated with the P2O5 to produce acetic anhydride, and the side product is water. Okay, so next is formation of amide. Okay, ammonium carboxylate, okay, react with this condition to form primary amide and water. So this one is secondary and tertiary amide can be synthesized by using the primary amide and secondary amide to produce secondary amide and tertiary amide. So next is decarboxylation of carboxylic acid. Okay, so this carboxylic acid undergo decarboxylate to form C double bond CO2 and also aliphatic carbon. So for this decarboxylation, there are three types. Okay, first look at the beta keto acid. This one is beta keto acid. Okay, readily decarboxylate at room temperature in acidic solution to form this ketone. Okay, decarboxylation of beta keto acid. Okay, this one acid, carboxylic acid. Okay, so this carbon designated for alpha carbon, and next alpha carbon is beta carbon, which is keto. We call as keto acid. Okay, undergo in the presence of proton acidic at low temperature, so the product is in ketone form. Okay, this one, okay, undergo to form the acetone enol first and proceed for the stable of product acetone. Number 2, by malonic acid and its derivative. So we want to decarboxylate using acidic solution and heat to form the propionic acid, to form the carboxylic acid from the malonic acid. This one is malonic acid. Okay, malonic acid means that there are two carboxylic acid and they undergo acidic solution, heat, and form this one carboxylic acid. Okay, but this reaction does not occur in base because of decarboxylation of beta keto acid. Both malonic acid and beta keto acid have carbonyl group beta to the carboxyl group. Okay, because of this structure, there are containing of carbonyl group beta, carbonyl group carboxyl acid. Okay, it's not a beta carbon. We call it as a beta carboxyl group. And last one is carbonic acid. Carbonic acid is unstable, so decarboxylate spontaneously occur in acidic solution to produce carbon dioxide and also water. So here is carbonic acid derivative. Okay, free carboxylic acid group will also decarboxylate, so decarboxylate under the acidic condition. Okay, here is for basic condition. Okay, so last one for your exercise. please try to understand the whole subtopic in the carboxylic acid. This one, chapter 4, only the basic. We discuss about the nomenclature, physical properties, how to prepare the carboxylic acid, and what is the reaction involved for carboxylic acid. Okay.